In this video, we're going to talk about section 1.1 dealing with review of functions. This is the first section in the Calculus 1 course. This is just basically just a review from material that was taught in previous courses like college algebra. So this first chapter is like a review. We'll start off with functions. And here's the definition of what a function is. It is a rule that assigns to each value x in a set D a unique value denoted as f of x. And the set D will be the domain of the function. The range is the set of all values of f of x produced as x varies over the domain. Okay. So here is pretty much some illustrations of what a function is. You have an input. Once you input a value x, what it does, it will calculate that value based on whatever the function is, and whatever the input is, you will get what they call an output, which is f of x. Okay. And also the domain and the range looks like this for a function. That means for every x value, you're only going to get one f of x value. That's it. Okay. Now, for the independent variable and the dependent variable. The independent variable is the variable that is associated with the domain, and your dependent variable belongs to the range. All right, the graph of the function f of x is going to be the set of all points x and y in the xy plane that satisfies the equation y is equal to f of x. And the argument of a function is going to be that expression on which the function works. So for example, x is the argument when we write f of x. Then similarly, 2 is the argument in f of 2, and x squared plus 4 is going to be the argument in f of x squared plus 4. Okay. So in this first example, pretty much we just do substitution here. If f of x is equal to 1 over x squared plus 3, what is f of 2? And what is f of p squared? So in this case, you just start off with what f of 2 is. And in f of 2, we just simply substitute the x in f of x with the value of 2. So it'd be 1 over x is replaced with 2 squared, and then plus 3. And then we just go ahead and simplify here. We'll have 1 over 2 squared, or 2 times 2 will be 4, plus 3. And then if I add 4 and 3 together, I'll get 7. So f of 2 for this function will be 1/7. Now, in this case, you got f of p squared. This time, we're not looking for a numerical value. We're just looking for an expression when we replace the x with p over p squared. So this would be 1 over x will be replaced with p squared. And then we got the square on the outside, so we need to bring that down. And then plus 3. And again, if you remember, when we raise a power to a power, you're going to multiply your exponents here. So let me bring over the 1. And then p to the second, and u squared will be p to the 4th. And then plus 3. And this will be the expression when your x is replaced with p squared in that f of x function. 1 over p to the 4th plus 3. And on the next page, here's example 2. Let's say we let capital F of x equal 1 over x minus 4. And we want to simplify this expression by evaluating f of y squared. So basically, all we're doing there is just substituting the x with y squared. And we'll get 1 over the x is substituted with y squared, and then bring down the -4. And I will go no further with that problem because even though I can factor y squared minus 4 as y plus 2 times y minus 4, y plus 2 times y minus 2, I'm not going to be able to simplify any further. So this is it. 1 over y squared minus 4. Okay, next example, example 3, we got if f of x is equal to x squared minus 2x, find f of 1, f of x squared, f of t, and f of p minus 1. So our f of x function is that x squared minus 2x. So let's start by finding out what f of 1 is. F of negative 1. So here, f of negative 1, we just substitute each x in f of x with negative 1. So this will be negative 1, and that's squared, minus 2 times x, which is negative 1. Now, negative 1 and u squared would be negative 1 times negative 1, which is 1. And then minus 2 times negative 1 will make that a plus 2. Add 1 and 2 together, you'll end up with 3. So the value of that function when x is negative 1 will be 3. All right, next is f of x squared. F of x squared, we just substitute each x again with x squared this time. So here we got x, which will be replaced with x squared, and that's going to be squared, minus 2 times x will be replaced with x squared. And then we just simplify. X squared and we squared, we're raising a power to a power, so we multiply the exponent. So it'll be x to the 4th, and then minus 2 x squared. And that would be as far as I can go with that problem. All right, f of t. Now here we're just replacing the x with t. So this x will be substituted with t. So it'll be t squared minus 2 times x will be replaced with t. And that's as far as we can go with that problem as well. So f of t for this function will be t squared minus 2t. And then f of p minus 1. F of p minus 1. Well, we replace the x, each x with p minus 1. So this x will be replaced with p minus 1, and that's going to be squared. And then minus 2 times, that x will also be replaced with p minus 1. Okay, so now let's simplify this. Now that p minus 1 quantity squared. Now I'm going to write this off to the side. Now p minus 1 is used as a factor twice. So we can write this as p minus 1 times p minus 1. And then we use the FOIL method. So here, p times p, first times the first, that's p squared. The outer, p times the minus 1 will be minus p. Then the inner, minus 1 times p will be another minus p. And then the last, minus 1 times a minus 1 will be plus 1. And now when we combine like terms here, we got p squared minus p and another minus p will be minus 2p plus 1. So p minus 1 quantity squared will be p squared minus 2p plus 1. Now for this minus 2 times p minus 1, we have to use the distributive property. Distribute the minus 2 over the p and the minus 1. So minus 2 times the p will be minus 2p, and then minus 2 times that minus 1 would be plus 2. And now we can combine like terms here. Right now the p squared minus 2p times another minus 2 I'm adding minus 2p and another minus 2p. I'm adding those. That would be minus 4p. Minus 1 plus, well, 1 plus 2 ends up being 3. So f of p minus 1 ends up being p squared minus 4p plus 3. Okay. So that's how we simplify and evaluate functions to get a particular output. Next, we'll look at the vertical line test. If you're given a graph, pretty much we can apply that vertical line test to determine whether or not we have a function. Okay. So a graph represents a function if and only if it passes the vertical line test. That means every vertical line intersects the graph at most once. A graph that fails this test does not represent a function. So like in this example here we have 4 graphs, and on each one of these, we want to determine whether they represent a function. So in that first graph that you see there, this graph A, if I draw a vertical line through that graph, you can see that this vertical line crosses the graph at only 1 point. So that means that this graph is a function. It is a function. And also, now part B has a graph that looks like this. It's a circle. And if you do this, draw that vertical line, you're going to see it's going to cross the graph at 2 different places. So this graph fails the vertical line test because it crossed the graph at more than 1 place. So this is not a function. Not a function. All right, graph C looks like this. Now I can draw the vertical line anywhere I want to. I can draw it on this side. You'll see that it's going to cross the graph at only 1 place. At only 1 place. So this graph is a function. And graph D looks like this. Now, if we draw the vertical line, you can see that vertical line is crossing the graph at 1, 2, 3 different places. Okay. It can only cross the graph at only 1 place. More than 1 place, it's not going to be a function. So this graph here, graph D, is not a function. Okay. And by the way, if you look at the y-axis, you're going to see that the graph crosses the y-axis at 3 different places. Okay. So that does help in determining whether or not you have a function for each of the graphs. Okay. And here's one more of these. You're going to use the vertical line test to determine, to decide whether graphs A, B, or both represent functions. Okay, what I'm going to do here is use different colors to distinguish between those 2 graphs that are given. Yeah, I'm going to let, probably not going to be able to see this, but let me do this here. This graph right here in blue, that's actually graph B. And I'm going to highlight this, well, I'm going to use black to represent graph A. Now, by using a vertical line test, we know at A, Here's A right here. If you look at graph A, which is the one that's in the black bold, it's crossing the graph at two different places. So graph A would not be a function, but graph B would. Because that graph is only going, well, that vertical line will only cross the graph at one place. Okay, so to answer the question here, only graph B, represents a function. Okay. All right, so that's the vertical line test and how it is used to determine whether graphs represent a function. Okay, now let's take a look at this example here. Here we're going to be using a graphing utility to graph functions here, like this one. And here we're going to be using the given window, and then we're going to state the domain and range of the function. Here we got f of x is equal to 4x to the fourth minus 10. And this is the given window. Our x values will be from -2 to 2. The y values will be from -12 to 16. Okay, so here is the graphing calculator that I'm going to put up here. Now, I'm going to enter this function f of x equal to 4x minus 10 in the calculator. So here I'm going to press this button that says y equal to. And if you've got stuff in here like I have here, you're going to clear those out. Now I'm going to go up to y1 and type in 4x to the fourth minus 10. So I type the number 4, and then the x will be the xt theta n button right here. And that's on the right side of the alpha key. Go press that button, and then the exponent of 4, I'm going to use the hat key for the exponent, and then type in 4. So that's 4x to the fourth. Use your right arrow key to get out of the exponential part, and then minus 10. Now to set my window to these dimensions here that's given, I'm going to press the button that says window at the very top of the calculator. Okay. Now, the -2 to 2 represents my x interval. So for x min, I'm going to type in -2, press the enter to go down to x max. That 2 will be your x max. Now I'm going to leave the x scale at 1. And now we're going to go to y min. These are your y intervals here. The -12 will be the minimum. So I'm going to type in -12. Now make sure when you're using that negative, this is the button that you press for the negative. Do not get this confused with this minus sign. The dash with the parentheses inside means negative of that number. All right, and then I'm going to press enter. Y max is 16. I'm going to type in 16. And I'm going to leave the y scale at 1. Okay. And now, next, I'm going to press the button that says graph. I'm going to graph this. And as you can see, this is what the graph looks like. Now, in the homework, you have to pick which one of these matches what you got here. And by looking at this, I'm going to choose answer A. Okay, because that's what that graph looks like. All right, so there's a graph of f of x equal to 4x to the fourth minus 10. Now we need to identify the domain and the range. Now the domain, since it is a polynomial function, any x value that you assign to it, you're always going to get an f of x value for it, no matter what. Because this, your x values, this goes on forever without end. So the domain In interval notation, by the way, let me underline that because they're going to tell you in the homework to type your answer in interval notation would be from negative infinity to infinity. That's going to be the set of all real numbers for the domain of this function. Now for the range. The range is going to be different because if we look at this, we need to find the lowest y value here, the lowest y value. So what I would do here is I'm going to press the second key, which is this blue key here, and then this button that says trace, because right above trace is to calculate menu. Now, in this graph, we're looking for the lowest y value that it would ever reach. So we need to select menu item number 3, which is minimum. Okay. Now you're going to get something that says left bound. What I would do here is use my left arrow key and position the cursor somewhere on the left side of the lowest point on the graph and then press enter. Then right bound would be by pressing the right arrow key, positioning that cursor to the right side of the lowest y value and then hit enter. Then after guess, I'll just go ahead and press enter. And I will be looking at the y value here. And in this case, the lowest y value that it would ever reach would be negative 10. Okay. So the lowest y value will be negative 10. And then it goes on and on upward forever. And there are infinitely many y values here. But the lowest it will reach is negative 10. So the range there will be from negative 10 to infinity. Okay. That's how we do that particular problem. All right, now let's look at another example. Let's say we want to graph the function z equaling to g of y equaling to y plus 1 divided by y squared minus 3y minus 18 with a graphing utility using the window -5, 9 by -3, 3. State the domain and range of that function. Okay. Now here you're given a choice of graphs to choose from and, of course, the choice for the domain and the range, and then you have to identify each. All right, what I would do here is press this y equal to key, clear out the previous equation in y1. Now, since it's a rational function, there's a numerator and a denominator. I would put the numerator and the denominator in parentheses. So the numerator will be left parentheses, xt theta n, I'm going to treat that y as x. So the x plus 1, close parentheses, and that's going to be divided by, the denominator will be in parentheses. And I'm going to treat the y as x as well. So press the xt theta n for the x, hit x squared to square it, and then minus 3 xt theta n for the x minus 18, close parentheses. And now for the window. Here's the window that they're giving us. So that -5 to 9 would be for x. So I'm going to press the window. My x min would be -5. X max will be 9. Leave x scale as 1. And then go down to y min, which is from -3 to 3. So your y min is -3. And then y max will be 3. X scale will remain 1. And then press graph. And this is what that graph looks like. So now again, you have to choose from what's given to you, which one of these matches this. And by looking at this, it matches graph B. So I'll select that. Okay, now we know what the graph looks like, and we're going to do this. Determine the domain of the function G. And you're going to select the correct answer choice below and fill in the answer box if necessary. Well, in this case, there are situations where we're going to get a 0 in the denominator. Okay, because for a rational function, if you remember back in college algebra, you want to find out what values of x that would give you a 0 in the denominator. And if you remember this, you can take that denominator, which is in this case y squared minus 3y minus 18. We can set that equal to 0 and solve for y and find out what values we give you a 0 in the denominator. Well, y squared minus 3y minus 18 is a quadratic equation. I can factor that into two binomials here. So y squared will break up as y and y. Factors a negative 18 that would give me 3y. Negative 3y will have to be minus 6 and plus 3. So I got y minus 6 times y plus 3 equal to 0. And then we set each binomial factor equal to 0 using a zero product principle. So it'd be y minus 6 equal to 0 and y plus 3 equal to 0. Each equation will solve for x. So for y minus 6 is equal to 0, that means y has to be equal to 6. And then for y plus 3 equal to 0 must mean y is equal to negative 3. So at negative 3 and 6, we're going to get a 0 in the denominator. So my domain will be the set of all y such that y is not equal to, and I'm going to enter these numbers separately, separated by commas. Y is not equal to negative 3, or y is not equal to 6. Because those are where I would get zeros in the denominator. And now let's determine the range of this function. For the range here, if we look at this graph, actually this goes on forever and ever without end. Goes on forever and ever without end. So actually the range is going to be the set of all real numbers. Okay, set of all real numbers. Okay. All right, and here's one more of these. Here we're going to graph the function with the graphing utility using a given window and then state the domain and range of the function. So here we got f of x is equal to the square root of 25 minus x squared. And the window is from negative 10 to 10 by negative 10 to 10. So this is actually the standard window. Okay, so use my graphing calculator. I'm going to press y equal to on the left side. Let's clear that equation out. Square root is going to be second and x squared. Second x squared gives you the square root. Then type in 25 minus xt theta n for the x, and then x squared to square it. Then I'm going to go to window. My x's will be from negative 10 to 10. So x min will be negative 10. And then x max will be 10. X scale remains as 1. And then for negative 10 to 10 on the y min is negative 10, but y max will be 10. Y scale remains as 1. And then we press graph. And this is what the graph looks like. for f of x equal to x, the square root of 25 minus x squared. Now let's choose which one matches this. And by looking at it, it'll have to be insert, has to be. And now we can find the domain and the range. Well, the domain is the set of all x values for this. Okay. Since this is in increments of 1, we go to the left 1, 2, 3, 4, 5. That's -5. And then to the right goes out to 5. So from -5 to +5, that would be the domain. Okay, that's the restriction here. -5 to 5. And notice that I'm using brackets here. And notice that it does say interval notation. And then for the range, well, notice I'm getting values between 0 up to +5. And that's as far as it goes from 0 up to 5, as you can see. 0 to 5, that's the range. Okay. All right, the next thing we'll look at is composite functions. Composite functions. Functions may be combined using sums like f plus g, or differences, which is f minus g, products, f times g, or quotients, f divided by g. The process called composition also produces new functions. Okay. So here's the definition of composite functions. Here you're given two functions, f and g, and the composite function of, which is this notation, f circle g, that's going to be defined as this, f circle g of x equaling to f of g of x. And that's evaluated in 2 steps. You have to do y equal f of u, where u is going to be some function g of x. And the domain of the f circle g consists of all x in the domain of g, such that u is equal to g of x is in the domain of the function f. Okay. So here, when we're dealing with the composition of f of g of x, your f is the outside function or the outer function. The g will be the inside function or the inner function. And this is just a representation of the composition of f with g. You start off with some input x, evaluate g of x for x, and you'll get u equaling to g of x. Then you take that, evaluate that, input that for your f of x, and you'll get the output, f of g of x. Okay. And another illustration of that would be this here. The domain of g, that's this. And now your g of x is the outside function. And now you have the range of g, which is also going to be the domain of f. And that's going to be put into f of x. You'll get f of g of x, which is the range of the composition of f with g. Okay. So now let's look at a few examples of this. Let's say we have f of x is equal to 3x squared minus x, and g of x is equal to 1 over x. And we want to simplify the following expressions here. So in part A, you got f of 5p plus 1. This is part A, f of 5p plus 1. So in this case here, we're just going to substitute the x with 5p plus 1 in the f of x only. So this is 3 times x is substituted with 5p plus 1. And that's squared because of the x squared there, minus, and the 5p plus 1 would be in parentheses. We're subtracting the entire 5p plus 1 from this here. And now we're going to simplify. Let's start off with, I'm going to bring the 3 over, but I'm going to start off by putting 5p plus 1 quantity squared. I'm going to do this off to the side. Now, of course, 5p plus 1 is used as a factor twice. So I'm going to write this as 5p plus 1 times 5p plus 1. Then I'm going to use the FOIL method. So in this case here, if I do 5p times 5p, that will be 5p squared. And then 5p times the 1 would be plus 5p. Inside, 1 times 5p would be plus 5p. And then the last times the last, 1 times 1 would be plus 1. And then if I simplify this, I'll have 5p squared. And then 5p plus 5p is 10p plus 10p plus 1. So that's what 5p plus 1 quantity squared would be. 5p squared. I'm sorry, 5p times 5p. That's 25. Okay. That's 5 times 5 is 25. All right, so let me correct that. So actually, I'll have 25p squared plus 10p plus 1. Now for that minus the 5p plus 1 in parentheses, I'm going to distribute the minus sign over 5p plus 1. So the minus times 5p plus 1 will be minus 5p. And then the minus times that plus 1 will be minus 1. So now I'm ready to simplify this as distributing the 3 over the 25p squared. That would be 75p squared. Distribute the 3 over the 10p. That'd be plus 30p. Plus distribute the 3 over the 1, be plus 3. Then minus 5p minus 1. And now I'm ready to combine like terms here. This will be 75p squared. 30p minus 5p will be 25p and plus 25p. Then 3 minus 1 will be plus 2. So 5p plus f of 5p plus 1 will end up being 75p squared plus 25p plus 2. All right, and that's what part A is. Now for part B, you got g of 1 over x. And g of x is equal to 1 over x. So we just replace the x with 1 over x. So it'll be 1 divided by, this x is substituted with this expression, 1 over x. Now 1 over x, 1 divided by 1 over x means this. If I was to write like this, 1 divided by 1 over x. And anytime you're multiplying fractions, you're always going to, divide fractions, you're always going to multiply by the reciprocal. That means we flip this fraction over. That 1 over x becomes x over 1. So you got 1 times x over 1. And of course, that's going to end up being x. Because 1 times x, that's x, and then x divided by 1 will end up being x. So g of 1 over x will end up being x. Okay. Now part C, we got f of g of x. That's the composition of f with g of x, which is written as f of g of x. Now here my inside function is g of x. G of x is equal to, in this case, 1 over x. So this will be f of 1 over x. All right, and now, look what we got. F of x is 3x squared minus x. So for every x, I'm replacing it with what g of x is in the f of x function. So since f of x is 3x, squared minus x, f of 1 over x will be this. 3 times that x will be replacing 1 over x, that's squared, minus x. Again, replace that with 1 over x. So in reality, I'm replacing for each x in f of x with what g of x is. All right, so now we need to simplify this. 3 times, square the 1, you're going to get 1. Square the x, you'll get x squared minus 1 over x. And 3 times 1 over x squared would be 3 over x squared minus 1 over x. And now if I want to simplify this, I can take the LCD of my denominators x squared and x. Here we use the variable with the highest exponent when we're finding the LCD. So here's going to be x, and the highest exponent is that square. So x squared would be the LCD. And then I write my equivalent fractions for this. I've already got x squared. If I want that x to be x squared, I need to multiply the numerator and the denominator by x. So that means I'm going to have 3 over x squared minus 1. Well, 1 times x will be x. 1 times x, that'll be x over x times x, that's x squared. And now I have 3 minus x over that common denominator of x squared. And that will be the final answer to that problem, to part C. And part D, g of f of x. Now this time, that's the composition of g with f of x. This time, f of x is your inside function. And your inside function, f of x, is equal to 3x squared minus x. So I'm going to replace f of x with this 3x squared minus x. So I'm going to be evaluating g of 3x squared minus x. But here g of x is 1 over x. So for every x in g of x, I'm going to substitute it with what f of x is. So if g of x is 1 over x, then that means g of 3x squared minus x will be 1 over, well, the x will be substituted with 3x squared minus x. And that's as far as I can go with that problem. Can't simplify it any further. Okay, now we got a couple of more examples dealing with the composition of functions here. Like, let's say I let g of x equal to x to the 4th and f of x equals to 1 over x minus 4. Here I want to simplify or evaluate the function f of g of y. So here I got f of g of y. This time my inside function is g of y. But I know what g of x is. That's x to the 4th. I want g of y, and I want that to be in terms of y. So if g of x is x to the 4th, then that means g of y. I just replace the x with the y. So g of y would be y to the 4th. Now let's substitute that y to the 4th with what g of y is equal to. And of course, g of y, of course, is y to the 4th. That's what that's equal to. And now my f of x is 1 over x minus 4. So for the x, we substitute it with the y to the 4th, which is what g of y is equal to. So it'll be 1 over x, we substitute that with y to the 4th minus 4. And in this case, I would go no further than that. So this is what f of g of y would end up being. 1 over y to the 4th minus 4. Okay, here's another example. F of x equal to x squared minus 9, and g of x equal to x cubed. And I want to simplify or evaluate the function g of f of u. Well, off to the side, let's do this. F of x is x squared minus 9. That would mean f of u would be this. We just substitute the x with the u, so it'll be u squared minus 9. And now let's find g of f of u. Now, in this case, your f of u is the inside function. We're going to substitute that with what it's equal to, u squared minus 9. So we're going to be evaluating g of u squared minus 9. G of u squared minus 9. And g of x is that x cubed. Okay, so since g of x is equal to x cubed, we just substitute the x with that u squared minus 9. So here, this will be just u squared minus 9, and that's going to be to the third power. And I will go no further than that. So this is what g of f of u will be, u squared minus 9, and that quantity is to the third power. Okay, and here's another example dealing with the composition of functions when you're dealing with a graph. Here we want to evaluate each expression using the graphs of y equal f of x, which is the one that's in red, and y equal g of x, that's the one that's in, actually the y equal f of x is in black, g of x is in red. Okay, so we want to evaluate the following here. Like in part A, you got f of g of 7. Inside function is g of 7. So let's find out what g of 7 is equal to. All right, now at x equals 7, because the number on the inside is your x value. So at 7, let's find out what g of x is. And in this case, it's 4, because g of 7 is 4. Now, since g of 7 is 4, now we can go ahead and find out what f of 4 is. So I'm replacing a g of 7 with what it's equal to. It's equal to 4. So we're going to find out what f of 4 is equal to. Let's go to 4 on the x-axis, go up to where this graph of y equal f of x is at, for x is equal to 4. And by looking at it, it's pretty much going to be at 7. So f of 4 will be 7. So f of g of 7 ends up being 7. All right, let's try g of f of 5. Here the inside function is going to be f of 5. So go to the x-axis, find 5. Your f of x is this graph that's in black. Let's go up here to find out where that value, what that y value is at x is equal to 5 for that y equal f of x. And as you can see, it's at 6. So f of 5 is 6. So now we can find g of 6. Since f of 5 is equal to 6, I'm just replacing f of 5 with what it's equal to. That's 6. So g of 6, let's go to 6 on the x-axis, go up to where this red graph, which represents y equal g of x, where does it intersect at? Or the point at x is equal to 6, the y value will have to be 3. So g of 5 equals 3. All right, point C, f of g of 8. F of g of 8. Let's start with the g of 8. That's your inside. All right. X equals 8. go to the red graph for 8, which is going to be this point right here. And the y value for that will have to be 5. So g of 8 is equal to 5. And then we replace g of 8 with what it's equal to, because we're going to find out what f of 5 is going to be. So let's go to 5. The black graph is what f is your f of x graph. So what's the y value at x is equal to 5 for y equal f of x? It'll be 6. So f of g of 8 ends up being 6. Now part D, g of f of 9. Inside function this time is f of 9. So let's find the value for f of x, this graph, when x is equal to 9. Here's 9. And it's right here. The y value for that is 7. So f of 9 will be 7. Now we're going to find g of 7, because that's what f of 9 is equal to. G of 7. So here's our g of x in red. At 7, we go up here from the point, and then the y value, which is going to be 4. So g of f of 9 would be 4. Now part E, we're finding f of 3. Let's start with the inside function, f of 3. So here f of 3, which is the one that's in black, at x equals 3, its corresponding y value for that will have to be 6. So f of 3 equals 6. Now we're going to find f of, now this time f of 3, which is equal to 6, we'll replace that with 6. So we're going to be finding f of 6, still using this black graph for y equal f of x at 6. Here's the point. It's going to be at 6. So the y value is 6. So f of 3 would be 6. And g of f of g of 4. Let's start with the innermost function, g of 4. And then whatever that is, we'll find what f of that, and then whatever that is, it'll be g of that. So starting with g of 4, using the g of x graph, at 4, that's going to be at the y value, which is 1. And now we're going to find f of g of x is now 1, so it'll be f of 1. That's what we're trying to find. Using a black graph, at x is equal to 1, that y value is going to be at 3. So it'll be f of 1 equaling to 3. And then finally, g of, this time we're going to substitute the 3 with f of g of 4, which is 3. So g of 3 at x is equal to 3. Here's the point. The y value for that would be 3. So our final answer for g of f of g of 4 would be 3. Okay, so that's how we use the composition of functions to evaluate them. All right, next we'll look at secant lines and difference and the difference quotient. Okay, you're going to see that slopes of lines and curves play a fundamental role in calculus. In this figure here that you see here, it shows 2 points, which is P, has the coordinates x and f of x, and Q, which has x plus h and f of the quantity x plus h on the graph of y equal f of x. So at P, this has the ordered pair x and f of x. The Q has the ordered pair X plus H. As you can see, here's X. If you go H places to the right, then you'll have X plus H. And that point there will be at F of X plus H. Now, the slope of the secant line, and this line that you see here, represents what we call the secant line. Okay, that right there is the secant line. And it's going to be a line that usually crosses the graph someplace, or the graph of a curve, in this case here. Now, if we take the slope of the secant line using the slope formula from college algebra, or from whatever algebra you've taken, it's a change in y divided by the change in x. So the change in our y value is going to be f of x plus h minus f of x. And then your change in your x value will be x minus h. Now, if you were to simplify this in the denominator, x minus x, that adds to 0. And you'll end up with f of x plus h minus f of x divided by h. Okay. So here, that slope formula is also known as the difference quotient. And it can be expressed in several ways depending upon how the coordinates of P and Q are labeled. Okay. So like if you're given the coordinates P, which is going to be A comma F of A, and Q being X comma F of X, then your difference quotient would be this. And this notation, M with the subscript of SEC, that is the slope of the secant line between 2 points, or through 2 points, which is going to be f of x minus f of a divided by x minus a. Okay, now this is very important here because when we get into things like finding the derivative of a function using a definition, you're going to be using a difference quotient in this case. So do be on the lookout for that when we get into future sections in this course. Okay. And here is the figure for that. If it was just P having the coordinates A and F of A and X and F of X, that would be your difference quotient. Now, there are some things that you do need to know. It's just a review, so do be aware of that. Difference of perfect squares is going to be x squared minus y squared. We can factor that out as x minus y times x plus y. Now, you might not have seen this with difference of perfect cubes, x cubed minus y cubed. Here, the cube root of x cube would be x. The cube root of y cube would be y. And then this part right here, we square the first term. And then we take the opposite sign of the product of the two terms inside the parentheses plus the square of the y term. And this next one is the sum of perfect cubes, x cubed plus y cubed. Okay. Cube root of x cube would be x. Cube root of y cube would be y. Then to get the second part, we square the first term. And then we take the opposite sign. Since the plus, the middle term would be a minus, the product of the two terms, x and y, and then plus the square of the last term. And then the fourth one, the sum of perfect squares does not factor over real numbers, x squared plus y squared. We can only factor differences of perfect squares, but not the sum of perfect squares, because it doesn't factor over real numbers. Okay. Now, we're going to use that difference quotient in this example. Let's say we got f of x is equal to x squared plus 9. F of x is equal to x squared plus 9. And we want to simplify or evaluate the expression f of 3 plus h minus f of 3, all divided by h. Okay, so what I'm going to do here is go ahead and write down my function f of x is equal to x squared plus 9. And I need to find out two things, f of 3 plus h and f of 3. Let's start with f of 3 plus h. Now for each x in f of x, I'm going to substitute it with the 3 plus h. So x is replaced with 3 plus h, and that quantity is squared, and then plus 9. Now here I'm squaring a binomial, so off to the side, I'll do this up here. I'm going to do 3 plus h quantity squared, and write that as 3 plus h times 3 plus h, since 3 plus h is used as a factor twice, and then apply the FOIL method. The first term times the first term. 3 times 3, that's 9. The outside 3 times the h will be plus 3h. Inside h times 3 will be another plus 3h, plus h times h squared. And now simplify this, this will be 9 plus 3h is 6h plus h squared. So 3 plus h quantity squared would be 9 plus 6h squared. 6h, just 6h. Okay. It's just plus 6h plus h squared. Then bring over the plus 9. 9 plus 9 gives me 18. So I'm going to write this in descending powers. H squared plus 6h plus 18. Now I need to evaluate f of 3. Well, just simply replace the x in f of x with 3. So this will be 3, and that's squared, plus 9. 3 squared, or 3 times 3, will be 9. 9 plus 9 is 18. Okay. So now I'm going to use that difference quotient. F of 3 plus h minus f of 3. Whole thing is divided by h. So in this case here, f of 3 plus h, we found that out to be h squared plus 6h plus 18 minus f of 3, we found that out to be 18. All that's divided by h. All right, so now what we can do here is subtract 18 minus 18, that's 0. You're going to be left with h squared plus 6h, all divided by h. Now in the numerator, I can factor out the h, because that's an h in h squared and an h in the 6h. So let's factor out the h. H squared divided by h would be h plus 6. The 6h divided by h will be 6, all divided by h. The h's divide out. You're left with just simply h plus 6. Okay. So using the difference quotient there, we have h plus 6. Okay, here's another example. All right, here we want to simplify the difference quotient, f of x plus h minus f of x divided by h for the given function. F of x equal to 7x minus 6. Okay, let's find out what f of x plus h will look like. Well, we just simply replace the x with the x plus h. So it'd be 7 times x plus h, then minus 6. Well, if I use the distributed property, I'll have 7 times x, which will be 7x, plus 7 times h will be 7h minus 6. Okay, so I know what x is. I know what f of x plus x is, and I know what f of x is. So let's use that difference quotient. F of x plus h minus the f of x. Whole thing is divided by h. So f of x plus h is this expression, 7x minus 7h minus 6. And then minus f of x is the whole thing, 7x minus 6. So I need to put all of that in parentheses. And this whole thing in the numerator will be divided by h. All right, next we'll simplify this. 7x minus 7h minus 6. This minus sign distributes, we'll get 7x. Then the minus sign distributes over the minus 6, it'll be plus 6. I'll divide it by h. Now, notice that 7x minus 7x, that's gone. Minus 6 and plus 6, again, that 2 is gone. You're only going to be left with expressions that have an h in it. And in this case, it'd be minus, correction, this should be plus, and that should be plus. So that means you'll just have 7h over h. And then h's divide out. You're left with 7. So here, this simplifies using the difference quotient. F of 7x minus 6 using the difference quotient will end up with 7. Okay. Okay, got a couple more of these. Here's one of those. This one has the x in the denominator. F of x equals to 11 over x. And here I want to simplify using the difference quotient. Okay. So that means I got f of x equal to 11 over x. That means f of x plus h. Just simply replace the x with x plus h. So this will be 11 over x plus h. And now we're going to use that difference quotient here. In this case, this will be f of x plus h minus f of x, all that's divided by h. And f of x plus h is this part right here, that 11 over x plus h, minus f of x, that's 11 over x. This whole thing is divided by h. So now I got a complex fraction that I need to deal with. And I need to clean this up a bit. And how would I be able to do that? Let's look at each of these individual fractions here. The x plus h, the x, and h is going to be over 1. What I'm going to do here is get a least common denominator of x plus h, x, and 1. Well, let's take each part. We got the x, and we got x plus h. And I'm just going to leave it as x times the quantity x plus h. Okay, that would be the LCD. So what I'm going to do here is multiply the numerator and the denominator by that LCD of x times the quantity x plus h. Okay, you'll see why. Now, in the numerator, I'm going to distribute that LCD over those two terms here. If I do 11 over x plus h times the quantity x plus h, what's going to happen here is that x plus h will divide out. And maybe it would help if I write it out this way: 11 over x plus h times, this without the parentheses, times x plus h, and then minus 11 over x times the quantity x plus h. You notice I'm running out of space here. Notice here the x plus h's are gone. I'm left with 11 times x, which is 11x. And then minus 11 over x times x plus h, x times x plus h, those x plus h's are gone. I'm left with 11 times x. I'm sorry, the x's are gone. I'm left with the x plus h times 11. So I have minus 11 times x plus h. Oh, that's over. I'm going to bring the h over times x plus h. That's this denominator right here, h, and then x times x plus h. All right, so now let's clean all this up a bit. If I can. The numerator, I'm going to have to use the distributive property. So here, this will be 11x, and then that minus 11 times the x will be minus 11x, and then minus 11 times the h will be minus 11h. All that's over h times, and I'll leave this as x times the quantity x plus h. All right, so now 11x minus 11x, that's gone. I'm going to be left with just negative 11h, negative 11h, equaling to h times the quantity x times x plus h. And notice that these h's are gone. They divide out, and we'll have this simplified as negative 11 over x times x plus h. And I will leave that just as it is. Okay. Okay, so for a problem like that, when you're using the difference quotient, you have to use the LCD. Multiply the numerator and the denominator times the LCD, and then simplify. Okay. All right, here's one more of these. This time we're using a polynomial function. And in this case here, we want to simplify using the difference quotient for this function, f of x equal to 3x squared minus 5x plus 1. Well, we got f of x. We're going to need f of x plus h. That means we just substitute each x in this function with the x plus h. So this will be 3 times the quantity x plus h, and that's squared, minus 5 times the quantity x plus h plus 1. Okay. Now that x plus h quantity squared, well, the x plus h is used as a factor twice, so I'll write this as x plus h times x plus h. And then use the FOIL method. First times the first. X times x would be x squared. Outer, x times h plus xh. Inner, h times x will be plus xh plus h times h squared. So I have x squared. I got 2 of these xh's, so this will be plus 2xh plus h squared. That's what x plus h quantity squared would be. So I'm going to have 3 times x squared plus 2xh plus h squared. Now for the minus 5 times x plus h, I'll use the distributive property. minus 5 times x is minus 5x, and minus 5 times h will be minus 5h, bring down to plus 1. Distribute the 3 of the x squared plus 2xh minus h squared. I'm going to have 3h squared plus 6xh plus 3h squared minus 5x minus 5h plus 1. And there are no terms to combine. So all of this represents f of x plus h. So now we're going to use a difference quotient here. So this is f of x plus h minus f of x divided by h. Now, f of x plus h is all of this right here. 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 1, and then minus, and in parentheses, what f of x is. In this case, f of x will be 3x squared minus 5x plus 1. That whole thing is divided by h. Okay, so now let's bring this part down. Distribute the minus over the 3x squared minus 5x plus 1, you'll get minus 3x squared, and then plus 5x minus 1. Minus times 3x squared is minus 3x squared, minus times 5x, minus times a minus 5x is plus 5x, minus times a plus 1 will be a minus 1. All that's over h. Now we can get rid of some terms here, like 3x squared minus 3x squared. That's gone. Minus 5x and plus 5x, that's gone. Minus 1 and a plus 1, this should be plus 1 right here. That's gone. Because you want to get rid of all the terms and you'll be left with nothing but terms that have h's in them. And also this should be 5h. So here you got 6xh plus 3h squared minus 5h, all divided by h. And now we can factor out the h. In the numerator, you'll be left with 6x plus 3h minus 5. All that's divided by h. And here these h's divide out. And all you'll be left with is 6x plus 3h minus 5. And that's as far as we'd be able to go here. Okay. So here, this is how we apply the difference quotient to these particular problems here. Okay. And I'll admit it's going to take a while and it's going to take time. So once you get practice of this, you should be able to come up with expressions using the difference quotient. All right, on the next page is example 17, dealing with interpreting the slope of a secant line. All right, so in this case, a function and an interval of its independent variable are given. The endpoints of the interval are associated with the points P and Q on the graph of the function. And so parts A and B. So here, after t seconds, an object is dropped from rest and it follows a distance d equaling to 25t squared, where d is measured in feet and t is between -2 and 7. +2 and 7. In part A, you're going to sketch the graph of the function and the secant line through PQ. Then we're going to find the slope of the secant line in part A and interpret your answer in terms of an average rate of change over the interval. And you're going to include units in your answer. Well, first of all, let's graph this function. D is equal to 25t squared using this interval for t. Okay, and then here they give you answer choices here. So notice that these y values here, the vertical axis, that will help me set up the range in the calculator, or the y min or the x min. All right, so let's go to y equal 2 in the calculator. Now I'm going to clear out what's in y1. And in that, I'm going to treat t as an x. So in y1, I'll type in 25. Xt theta will give you the x, and then x squared squares it. And now for the x min and the y min from 2 to 7. Go to your window. Your x min would be 2. And then your x max will be 7. X scale remains as 1. But let's look at the vertical axis here. This is from 0 to 2,500. So I'm going to let x min be 0. And then x max will be 2,500. And notice that it's in increments of 500. So I'm going to let the y scale be 500. I'm going to type in 500. Okay, and then press graph. Just to see what that graph is going to look like. Okay, kind of looks like this. So in this case here, and by the way, let's change the window from, and they're using 0 to 10. So let's say 0 and then 10 and let the x scale be 1. That way I'll get a better idea of what that graph is going to look like. Okay, and they're doing points from 0 to 10. So it'd be better to do it that way. Okay, so the answer choice that I would use, I would not use B, C, or D, because the graph doesn't look like that. It's going downward. It's actually going upward. So it has to be either A or B. Okay. And if you notice here, if you look at B, that point right there is at where x is equal to 7. So let's use that. A wouldn't work because that point right there is at t is equal to 10. So answer choice B in this case would be the choice. All right, let's do this here. From 2 to 7, I'm letting T1 be 2 and T2 be 7. Okay. Now at t equal to 2, using d is equal to 25t squared, that would mean that d will have to be 25 times 2 squared. Well, 2 squared would be 4, so 25 times 4 would be 100. And for T2 being 7, D will be 25, and I'm going to label this D1, this will be D2. This will be 25 times 7 squared. 7 squared is 49, so 25 times 49 would be 1,225. So that's what D2 is. And D1 would be 100. So I'm going to be using the slope formula, or the slope of the secant line, which is going to be, in this case, D2 minus D1 divided by T2 minus T1. And D2 is 1225 minus D1, which is 100, all divided by T2, which is 7, minus T1, which is 2. So 1225 minus 100 would be 1125 divided by 7 minus 2, which is 5. This is actually 1,225 feet for 5 seconds. T is in seconds. So 1125 divided by 5 will end up being 225. And this is going to be in feet per second. Okay. Because the distance is in feet, the time is in seconds. Okay. So to fill in part B, the slope of the secant line is, 225. And that means that the object falls at a average rate. And here they're giving you the answer choices here. In the homework, they'll give you a drop-down menu to select an answer. So it's falling at a rate of 225. And of course, feet per second. Okay. So with your answer choices, usually they give you a drop-down menu to pick your correct answer that best fits that problem. Okay. All right, the last thing we'll look at is symmetry. Now, the word symmetry does have many meanings in mathematics, but here we consider symmetries of graphs and the relations they represent. Taking advantage of symmetry often saves time and leads to insights. So let's talk about symmetries that are related to graphs here. A graph is symmetric with respect to the y-axis if whenever the point x comma y on the graph, the point negative x comma y is also on the graph. Now this property means that the graph is unchanged when reflected about the y-axis. Okay, if you remember back in college algebra, if you have something that's a graph being symmetric with respect to the y-axis, you substitute x for negative x, you'll get the original function back. That's something that is an even function, and it is symmetric with respect to the y-axis. Now, for a graph that's symmetric with respect to the x-axis, it's going to be whenever the point x comma y is on the graph, the point x negative y is also on the graph. So this property means that the graph is unchanged when reflected about the x-axis. And of course, symmetric with respect to the origin, that's whenever xy is on the graph, the point negative x negative y is also on the graph. When it's symmetric with respect to the origin, that means every single term changes to the opposite sign. That's going to be an odd function. Symmetry about both the x and y axis implies symmetry about the origin, but not vice versa, not the other way around. Okay, so on the next page is an illustration of that. The first graph that you see is symmetric with respect to about the y-axis. Here's the y-axis. The right side has the mirror image of the left side. And about the x-axis, here's the x-axis going this way. The graph on top is symmetric, has a mirror image of the part that's on the bottom. And of course, symmetry about the origin is the origin. If I was to take this top part in this quadrant, rotate this, it should fit perfectly on top of the bottom part of this graph in that third quadrant. Okay. Now, I did mention the phrase even and odd functions here. Here's the definition. An even function has the property that where f of negative x equals the original function f of x for all x in the domain. So the graph of that even function will be symmetric about the y-axis. And then an odd function where f of negative x equals to the opposite of the original function f of x. That's where each and every term must change to the opposite sign. And this for all x in the domain. For an odd function, its graph will be symmetric about the origin. Okay, and they also add that polynomials consisting of only even powers of the variable of the form x to the 2n, where n is a non-negative integer, are even functions. Polynomials consisting of only odd powers of the variable of the form x to the 2n plus 1, where n is a non-negative integer, are odd functions. All right, on these final two examples, we're going to determine whether the graph of the following equation or function has symmetry about the x-axis, the y-axis, or the origin. And we'll check by graphing, or I'll let you check by graphing. In this case here, f of x equal x is 6 minus 5x to the fourth plus 8. But in either case, to determine whether it's even or odd, you always substitute each x in that function with negative x. So in this case here, that x would be negative x, and it's to the 6th power, minus 5, and the x is substituted with negative x to the 4th power, plus 8. Now, a negative to an even power is always going to be positive. So negative x, you raise to the 6th power, that'd be positive x to the 6th power. And then minus 5 times, again, that negative x is to an even power, that's going to be positive. So just be x to the 4th plus 8. Compare that f of negative x with our original function. It's the same. So that means we have an even function. And if it's an even function, it must be symmetric about the y-axis. Okay. Okay, now this is what the graph looks like here. And I've already typed in this. I'm going to try to fit this graph. Okay, so here's a pretty much better look at what the graph looks like. Okay. All right. Not working for me, but that's okay. It is symmetrical about the y-axis. Now, for this last one, example 19, determine whether the graph of the following has a symmetry about the x-axis, the y-axis, or the origin. You'll check your work by graphing. All right, if we look at doing this, f of negative x, this is f of x equal to x cubed plus x plus 5. Substitute each x with negative x, you get negative x, and that's cubed plus negative x. We substitute that with negative, that x with negative x, and then plus 5. A negative to an odd power would be negative. So this has to be negative, x to the 3rd, plus negative x will be minus x plus 5. Got a problem with this one. The first and the second terms changed to the opposite side. The last term did not. So this graph is neither even nor odd. Neither even nor odd. So here, this will not be symmetric. It's not going to be symmetric about either the x or the y or the origin. Okay. So sometimes you may have a function that is neither even nor odd. It is not going to have symmetry. Okay, so that will conclude this video on section 1.1, dealing with the review of functions. Also, feel free to email me if you have any questions about the homework that's in my math lab or anything that's been presented in this video.